Hello there, Mr. Sutton here, bringing you the IM3 Honors 1-4 Part 1 homework solutions on inverse functions.
For number 1, we're finding the inverse for this function. Now this is just a line, so it should definitely have an inverse, passes the horizontal line test. Let's start by switching x and y. So we'll write x equals 3y minus 5, and then just solve for y. So add 5 to both sides, divide by 3. So we can write f inverse of x equals x plus 5 over 3. For number 2, we're trying to find the inverse for this function. Now this is a horizontal line. It's just a constant right here. So it's going to fail the horizontal line test. So this does not even have an inverse. For number 3, we're trying to find the inverse of this square root function. Square root function passes the horizontal line test. So let's go ahead and start the process. We'll switch x and y. X equals square root of y minus 5 would be a good first step. And then to get y by itself, we first have to square both sides to get rid of that square root. So we've got x squared equals y minus 5. And as a last step, we'll just add 5 to both sides to get f inverse equals x squared plus 5. For number 4, we're trying to find the inverse of this thing. Now the square root doesn't really cause any problems. However, this x squared right here is going to cause this thing to not have an inverse because negative and positive inputs both give you the same output. So if you're given the output, you don't know which input you had in the first place. So this does not have an inverse. To find the inverse function on this one, we're going to switch x and y and then solve for y. So I've got x equals negative 20 plus y over 5. And then to solve for y, I have to first get rid of this fraction by multiplying 5 by both sides. So we'll have 5x over there. And then we just have to add 20 to the other side. So I can write g inverse equals 5x plus 20. For this problem, we need to figure out the inverse for this function. So we're going to start by first making sure that it can be inversible. There's no even exponents or absolute value here, so I think we're good to go. Let's go ahead now and actually take the inverse. We're going to do that by switching the x and y values. So I'm going to write this as x equals negative 2y plus 11, switching the input and the output variables there. And now we're just going to solve for y. So we can start by subtracting 11 from both sides. And then we have to divide by negative 2. So I'm going to have, we'll call this f inverse equals x minus 11 all over negative 2. To find the inverse function for this one, we're going to switch x and y in the beginning. So we have x equals negative 3 plus 7/3 y. Next, we have to get y by itself. So let me start by adding 3 over to the left side. And then to get y by itself, I've got some options here. The fastest way would be to multiply both sides by the reciprocal of this, so 3 over 7. And we can write then g inverse equals 3/7, parentheses x plus 3. Or if you wanted to simplify it a little more, we could do 3x plus 9 all over 7, just distributing that 3 and then dividing everything by 7.